Hello guys, today we are going to study sets and operations. Okay, so before we begin with the lesson, let's look at some objectives before we begin. So by the end of the lesson, you should be able to define sets, describe and write sets, and also to distinguish between the types of sets. Okay, so let's begin. What is set? Set is a well-defined collection of objects of the same kind. So when you have a collection of objects which have similar properties, basic features, it becomes a set. Okay, so let's look at some of the examples of set. So we have a set of fruit. Okay, so for example, you go to the market with your basket going for fruits, and then you buy your apple, your banana, your pear, and your orange. So having the basket full of this fruit makes it a set. So the well-defined object becomes the fruits in the basket. Okay, so let's look at the example. So we have a set of first 5 alphabet. So with first 5 alphabet, we know that it is A, B, C, D, and E. So this becomes a set. And then we have a set of even numbers. When you talk about even numbers, we are talking about numbers that are divisible by 2. That is, it can be divided by 2. And so all this, so we have a set E, which is equal to 2, 4, 6, 8. Okay, so in short, we are trying to say that a set is represented with a capital letter. So most of the time when you are given a set, it has an initial capital letter, and then it also has a curly bracket, and then inside the curly bracket we have objects, well-defined objects, which are called members or elements. So the objects in the curly bracket are called members or elements. Okay, so in describing set, we may have 3 ways of describing set. The first one is listing its members. So the set is already given, and then its members has already been listed for you to use. Okay, so with the second one, defining the property of the set, we are using the same example which is in the first one, that is listing its members. The example in the first one, that is what we are going to use for the second one. And then when you take defining the property of the set, it is all about defining the set so that the person or the individual who is involved will be able to list the members. So with the first one, which is P, the P is even numbers less than 10. When you move to listing its members, you know that our P is 2, 4, 6, 8. So it is less than 10, and it's also even number because even number is divisible by 2. Okay, good. So our Q is natural numbers, and then our R is odd numbers less than 20, odd numbers less than 20. And then lastly, we have using a set builder notation. So when we talk about set builder notation, it's all about using operational signs to define your element or your object. Using operational signs to define your elements or members. Okay, so let's move to the next one. Okay, so let's look at some of the types of sets. Firstly, we start with finite set. So when a set is given and its last member can be found, it is called finite set. So a finite set is a set whose last member can be found. So member or element can be found. What's infinite set? Infinite set will be the opposite of finite. So if its last member can't be found, then it becomes infinite set. So it's a well-defined collection, which is a set whose last member can't be found. Next type, we have the unit set. When we talk about units, we are talking about 1. So a unit set is a set which has only one member. So when you have a set and you have only one member in the set, it becomes a unit set. Next type, we have the null set. When we talk about null set, we are talking about nothing. So 0, nothing. 0 is something. Null means nothing. So it's a set which has no member at all. It has no member at all. So the symbol to represent the null is P, and then you have your curly bracket with nothing inside, or the other symbol on your screen. So we continue with the types of set. We have subset. So subset can be dealt with in two ways. The first one is getting smaller sets out of a bigger set. So when you have this example, P equal 1, 2, 3, how many subsets can we find out of the P? We can get 8. P1, P2, P3, P4, P5, P6, P7, P8. So you can get 8 subsets out of the original set. So if a question is given and you are told to find the number of subsets in a set, you are going to use the formula 2 exponent n to find the number of subsets in a set. And then another way of dealing with subset is when you have two sets in consideration, and then one of the sets can be found in the order. The smaller one becomes a subset of the bigger one. What do I mean? I mean, let's take for example what I have on the screen. P is 2, 4, 6, and then our Q is 2, 4, 6, 8, 10. So from the screen we can know, or we know, that P, which is 2, 4, 6, can be found in Q. 2, 4, 6 can be found in Q, and therefore P is a subset of Q. So it means that P can be found in Q. So since all the members in set P can be found in set Q, therefore the set P is a subset of set Q. So this is how we write it with a subset. So the symbol for subset is what you see without the dot. I couldn't get an exact subset symbol. So without the dot, please don't use the dot. Thank you. Okay, so let's continue with the type. We have universal set. Universal set becomes like the mother set of all the set under consideration. All the set under consideration. So it is a bigger set where all the other set become a subset too. So the symbol for universal set is a big U, something like a big U. Okay, so let's continue. Intersection of sets, taking into consideration set A and then set B. When we talk about intersection, we are talking about common members in two sets. Common members in two sets. So when you have two sets under consideration, say A and B, where A is 1, 4, 6, 8, and then our B is 2, 4, 8. So the intersection, what will the intersection be? What is common in set A and also common in set B? I mean, what can you find in set A which can also be found in set B? So we have 4, and then we also have 8. So A intersection B is 4 and 8. So the symbol for intersection is what we have as a n, a stretched out n. Let's move to the other type of set. We also have the union of sets, taking into consideration set A and then set B. It is not always going to be set A and set B. It could be anything. It could be set P, Q, set R and set T. It could be anything. So we are using A and B under consideration. So when we talk about union of sets, we are talking about merging two sets to form one bigger set. So when you are given two sets A and B, where A is 1, 4, 6, 8, and then B is 2, 4, 8, then you merge it together. So if you have 4 here, 4 here, you just take 1. So it becomes just 1, 4. You don't write all the 2, 4. So we have, when you combine A and B, you are going to get 1, 2, 4, 6, and 8. So the symbol for union is kind of like U. Yeah, that's the symbol, but a smaller one, because the universal set, which is also a bigger U, is indeed big. Okay, let's move to the next. Okay, so let's look at the next, which is complement of a set. So let's say we have a set A, and then we also have a universal set. Then what will be a complement? of set A? What will be the complement of set A, which is like a prime? That is how it is mentioned, A prime. Okay, good. So if you are looking for the complement of a set which is A prime, it will be members that are in the universal but they are not in the set A. So if you are given a set, let's take the example under consideration. We have U, which is the universal, then we have Q, which is 4, 6. So the set Q has members 4 and 6, and then the universal set is 2, 4, 6 and 8. So the complement, which is the Q prime, the complement of Q, will be members that are in the universal set but they are not in the original Q set. So members which are in the universal set but they are not in the original Q set is 2 and 8. So the complement of Q is 2 and 8. The complement of Q is 2 and 8. Okay, so the next one is disjoint set of two sets. So taking two sets into consideration, which is A and B. So mostly disjoint set is like the opposite of intersection. With intersection, we are looking for common members or elements that belongs to the two sets. But with the disjoint set, it means that there is nothing common about the two sets. So when you are given two sets, P, which is 2, 4, 6, and then you're also giving Q, which is 1, 3, 7. There's nothing common. There's nothing common about these two sets, and therefore their intersection will give you an empty set. So anytime you have two sets and their intersection gives you an empty set, it becomes a disjoint set of that two set. In our next video, we are going to do examples on whatever that we have learned in this very lesson, and I hope you will subscribe below to get notification of the next video. Thank you.